I want you to look up at the sky tonight. Just stop. Go outside and look up. You will see light. Thousands of points of light scattered across the darkness. And you will think to yourself, I am looking at the stars. But I must tell you something that should disturb you. Something that should shake loose every comfortable assumption you have ever made about the nature of time and reality. You're not looking at the stars. You're looking at the past. And if I am right, if the physics is right, that past is not gone, it is not dead, it is not a memory, it is still happening. Right now, as you read these words, as you breathe, as your heart beats, ancient light is arriving at your eyes, carrying news from a universe that existed millions of years before you were born. And the question I want you to sit with today is this. If the light from the past is still arriving, does that mean the past is still real? This is not a philosophical riddle I am posing for entertainment. This question sits at the very intersection of physics, light, and the deepest mystery of what we mean when we say the word now. Let me begin where I always begin, with light, because light is perhaps the most profound thing that exists in this universe. It is the messenger, the traveler, the thread that connects all moments to all observers. And its behavior, its strange and beautiful behavior, is the key that unlocks everything I wish to show you today. When I was a young man in Paris, still deeply under the influence of the work of Einstein and Planck, I became obsessed with a particular question. What is light, really? Is it a wave? Is it a particle? The answer, as I eventually came to understand, is that it is both simultaneously, until observation forces it to reveal one face or the other. But this wave-particle duality, this fundamental strangeness at the heart of light's identity, was only the beginning of what light has to teach us. Because light has another secret, one that concerns not what it is, but how it moves through time. Light travels through empty space at a speed of approximately 299,992 kilometers per second. This number, this constant, is one of the most important facts in all of physics. It is not simply fast. It is the absolute speed limit of the universe. Nothing with mass can reach it. Nothing can exceed it. And the reason this matters so deeply to our conversation today is because this finite speed means that light takes time to travel. It takes real, measurable, irreversible time to cross any distance. Now let us start with something close to home, something you can feel in your bones, and then we will stretch the idea outward until the universe itself looks different to you. The light from our own sun, that enormous furnace of nuclear fire 150 million kilometers away, takes approximately 8 minutes and 20 seconds to reach your face when you step outside. You do not feel this delay. It does not inconvenience you, but consider what it means. When you look at the sun, you are not seeing the sun as it is at this moment. You are seeing the sun as it was 8 minutes ago. The sun you are looking at is, in a very real and precise physical sense, a sun from the past. Now that sun still exists, very likely because 8 minutes is not very long in the lifespan of a star. So in this case, the delay is almost inconsequential. But stay with me, because we are about to travel much further. When you look at the moon on a clear night, you are seeing it as it was 1.3 seconds ago. When you look at Jupiter, you are looking back in time approximately 48 minutes, depending on where it sits in its orbit relative to us. Already, the solar system begins to feel like a collection of ghosts, real objects sending us light messages from their recent pasts. But now, let us leave the solar system entirely. Let us turn our eyes outward to the stars. The nearest star to our sun is Proxima Centauri, at a distance of approximately 4.24 light-years. 1 light-year is the distance that light travels in 1 full year, roughly 9.46 trillion kilometers. So the light you see when you look at Proxima Centauri in the southern sky left that star more than 4 years before it arrived at your eye. You are not looking at a star as it is now. You are looking at a star as it was 4 years ago. That star may have changed. It may have dimmed or brightened. We cannot know yet because the new light has not arrived. Now look at the stars of the Big Dipper. The constellation so familiar that children learn it as one of their first lessons in astronomy. The stars that form this shape are between 60 and 125 light-years away from us. The light you receive from the handle and the cup of that dipper set off on its journey when your grandparents or their grandparents were alive. You are witnessing the light of a past century, arriving in the present moment, landing on your retina, convincing you that you are seeing something current. And the further we look, the stranger and more extreme this becomes. There is a star cluster called the Pleiades, the Seven Sisters, which has captivated human imagination for thousands of years. The Pleiades sit approximately 440 light years away. The light that reaches us from the Pleiades began its journey around the year 1585, when Elizabeth I was on the throne of England, when Shakespeare was just beginning his career, when the modern world as we know it had not yet been born. That light has been traveling through the vacuum of space for over 4 centuries, and it arrives at your eye tonight as though it is brand new. Betelgeuse, the red supergiant star that marks the shoulder of Orion, one of the most famous and easily recognized stars in the night sky, is approximately 700 light years away. The light we see from Betelgeuse tonight left that star in the 1300s, during the time of the Black Death in Europe, when the Mongol Empire was reshaping Asia, when the Renaissance had not yet begun. Scientists believe Betelgeuse is approaching the end of its life. It may already have exploded. It may already have gone supernova, in a blaze of light so intense it would briefly be visible in our daytime sky. But that explosion, if it has already happened, will not become visible to us until its light has crossed those 700 light years. We are, in a deeply uncomfortable sense, waiting for news that is already on its way. And then we have entire galaxies. Our nearest large galactic neighbor, the Andromeda Galaxy, is approximately 2.5 million light years away. When you look at that faint smudge of light in the autumn sky, the light entering your eye began its journey 2.5 million years ago. At that time, our ancestors, our very early ancestors, were walking the African savannah with brains not yet fully human, with no language, no fire, no concept of anything beyond the immediate horizon. That light has been crossing the void of intergalactic space for the entire history of human evolution and prehistory, and it is arriving now, touching your eyes, creating an image in your mind of something you call the present sky. You understand what I am building toward. Every single thing you see when you look at the night sky is the past. Not a representation of the past, not a symbol of the past. The actual physical light of the past arriving in your present. The sky above you, at every moment of every night, is a map of time as much as it is a map of space. When you look further away, you look further back. The James Webb Space Telescope, that extraordinary instrument that humanity has launched into the cold of space, has peered back to galaxies that existed when the universe was only a few 100 million years old. We are receiving light that has been traveling for nearly 13 billion years. We are looking at the infancy of the cosmos. Now here is where I need you to make a conceptual leap with me, because so far what I have described sounds like a limitation, a delay, a lag, an inconvenience of the finite speed of light. You might say, yes, the light is old, but the stars are new. We are simply receiving delayed signals from a present that exists elsewhere. You might think of it like receiving a letter that was written months ago. The letter describes the past, but the person who wrote it is still very much alive and in the present, perhaps already living a different life. And that framing makes sense when the objects we are discussing are close by and long-lived, like our sun. But now I want to push this further into territory where it stops being comfortable. Because the block universe theory does not simply say that light is delayed. It says something far more radical. It says that the past moments, those photons left behind, those exact configurations of matter and energy have not simply vanished. They still exist. They are as real as anything happening right now. To understand this, we must follow the thread that Einstein laid before us. Einstein's theory of special relativity did something that had never been done before in the history of physics. It wove space and time together into a single fabric. Before Einstein, space was the stage and time was the clock. They were separate things. Objects moved through space while time ticked neutrally overhead. But Einstein showed that this is wrong. Space and time are not independent. They are aspects of a single entity that Hermann Minkowski, Einstein's former teacher, gave the name Spacetime. In space-time, every event has 4 coordinates, 3 of space and 1 of time. And the structure of space-time is such that it contains all events, all moments, all that has ever happened or will happen. The Big Bang is there. The formation of the stars is there. Your birth is there. Your death is there, somewhere ahead of you, in the geometry of this 4-dimensional structure. Everything that exists within this block. This is why physicists and philosophers call it the block universe. The universe in this view is not a dynamic, flowing, ever-changing present that constantly destroys the past and reaches toward an uncertain future. It is more like a sculpture, a 4-dimensional sculpture in which every moment, every event, every particle's position at every instant of time is permanently inscribed. Nothing is erased, nothing flows away. The past does not cease to exist when the present moves on. The past is still there in space-time, exactly as it always was. And now light becomes the most extraordinary evidence for this view, because if every moment in the history of the universe is still encoded in the structure of space-time, then the light currently traveling through space is the proof. The photons that left Andromeda 2.5 million years ago are not carrying information about a dead past. They are the living fingers of that past reaching forward through space, touching your eye, connecting your present to their origin in a causal chain that has never been broken. The moment those photons were emitted, that precise cosmic instant 2.5 million years ago is still real. It still exists as a coordinate in space-time, and the light it produced is still in motion, still crossing the void, still keeping the connection alive. Think about what this means for our intuitive sense of time. We experience time as a river. We are always in the present moment. The past is behind us and unreachable. The future is ahead of us and uncertain. This is how time feels from the inside. But special relativity tells us that this feeling is an illusion. More than an illusion, it is a local perspective. The sense of now that you carry with you, the feeling that this moment is the only real moment, is something that belongs to you, to your particular position and motion in space-time. Someone else moving at a different velocity through the universe would have a different now. They would disagree with you about which events are happening at this very moment. This is what physicists call the relativity of simultaneity. 2 events that appear simultaneous to one observer may appear to happen at different times to another observer, moving relative to the first. And this is not a trick of perception. It is not an illusion caused by the finite travel time of light or the limitations of our instruments. It is a genuine feature of the geometry of space-time. There is no absolute universal now that stretches across the entire cosmos. What you call now is yours, and mine is mine, and a traveler moving between the stars would have yet another. And if there is no universal now, if every observer carries their own present moment like a lamp that illuminates only their local section of the 4-dimensional block, then what basis do we have for saying that any moment is more real than another? Why should now, your present moment, be considered uniquely real, while the year 1850, or the year 4000, or the year the Andromeda galaxy was young and bright and full of newly forming stars? Why should those moments be considered unreal, gone, destroyed? The block universe theory answers they shouldn't be. The year 1850 exists as a slice of the 4-dimensional block just as surely as 2025 does. The ancient past in which that light from Andromeda was first emitted exists as a slice of the block just as surely as your present moment does. All moments are equally real. All moments exist. The past has not vanished. It is there, fixed in the geometry of space-time, as permanent as geometry can be. Now, I know what some of you are thinking. You are thinking, this is philosophy, not physics. You are thinking, we cannot go back and verify that the past still exists. You are thinking, this sounds like science fiction dressed up in the language of relativity. So let me bring it back to something concrete. Let me bring it back to light. Consider the cosmic microwave background, the oldest light in the observable universe. Approximately 380,000 years after the Big Bang, the universe had cooled enough that protons and electrons combined to form neutral hydrogen atoms. Before this moment, the universe was a hot, dense, opaque plasma, and light could not travel freely through it. It scattered off the charged particles like a thick fog. But when neutral atoms formed, the fog lifted and light could travel freely for the first time. That light, the light of that first moment of transparency, is still traveling. It is still crossing the universe, stretched and cooled by the expansion of space into the microwave portion of the electromagnetic spectrum, but it is still real, still physical, still carrying information about its origin. We detect it with our instruments. We make maps of it. We study the slight temperature variations in it that tell us about the distribution of matter in the early universe. That light was born in a universe that looks nothing like the one we live in today. The stars had not yet formed. Galaxies did not exist. There was no Earth, no sun, no solar system. But the light from that era is here, right now, washing over us, carrying the physical imprint of a moment that existed nearly 14 billion years ago. Is that moment gone? Or is it simply far away, both in space and in time, and still, in some deep sense, real? I have always believed, and my work on wave-particle duality has only reinforced this conviction, that nature does not waste things. The universe does not casually destroy its own history. Every configuration of matter and energy that has ever existed, every event that has ever unfolded, leaves a trace. Sometimes the trace is a fossil, sometimes it is a gravitational ripple spreading outward through space-time, and sometimes it is a photon, a single quantum of light launched outward at the moment of an event and still traveling, still carrying its payload of information through the vast dark spaces between the galaxies. In my work, I discovered that matter, not just light but matter itself, has wave properties. Every particle has a wavelength associated with it, related to its momentum through a simple relation involving Planck's constant. This means that the universe at its most fundamental level is not made of hard little billiard balls bouncing around through empty space. It is made of something far stranger, something that is simultaneously spread out in space and localized in interaction, something that does not have a single definite position until it is observed. The quantum world is a world of potentialities, of superpositions, of things that are in some sense everywhere at once until the moment they are forced to choose. And this quantum strangeness, when you combine it with the space-time geometry of relativity, leads to some of the most profound and unsettling conclusions in all of physics. One of them is the block universe, because if space-time is a four-dimensional geometric structure, and if quantum mechanics tells us that events are inscribed in this structure with a precision that makes them permanent, then the past is not simply historical. The past is geometrically real. The past is a region of space-time, just as distant galaxies are regions of space. You cannot visit them easily, but they exist. Think of it this way. Suppose you are standing in a city and someone tells you that Paris exists. You cannot see Paris from where you stand. You cannot directly experience Paris at this moment, but you do not conclude from this that Paris does not exist. Paris exists. It is a real place. It is simply not here. Now apply the same logic to time. The year 1924, the year I defended my doctoral thesis in Paris, the year I showed the world that matter has wave properties, that year exists. You cannot visit it. You cannot directly experience it right now. But the same logic that assures you Paris exists, applied to the geometry of space-time, tells you that 1924 is a real location in the four-dimensional block of the universe. And the light is our evidence. The light is our proof. Every photon currently crossing the interstellar and intergalactic void is a physical object that was launched from a real past event and is maintaining a real physical connection between that event and the future moments in which it will be absorbed. Those photons do not come from nowhere. They do not materialize from a void. They come from specific definite events that occurred in specific definite locations in the past, events that are as real as anything happening this instant. Now, I want to address something that troubles many people when they first encounter the block universe. They say, if the past still exists, if all moments are equally real, then the future also already exists. And if the future already exists, then everything is predetermined. Free will is impossible. The choices you think you are making are not really choices at all. They are simply the fixed coordinates of events already inscribed in the block. This is a profound concern, and I do not want to dismiss it lightly, but I think it rests on a confusion about what the block universe is actually saying. The block universe does not say that you do not have experiences. It does not say that your sense of deliberating, choosing, acting is an illusion. What it says is that those experiences, your deliberations, your choices, your actions, are themselves real events inscribed in space-time. Your freedom, if you have it, is not freedom from the block, it is freedom within the block. The question of free will and determinism is a genuinely hard one, and the block universe does not resolve it, but it does reframe it. Your choices happen. They are real, they are part of the structure. Whether they were in some sense fixed in advance is a question about causality and quantum mechanics that even the best physicists and philosophers have not yet fully resolved. What the block universe does most powerfully is challenge our intuition that the present moment is the only real thing. It challenges the assumption so deeply embedded in our psychology and our language that the past is gone and the future is not yet here. Both of those intuitions are parochial. They are the intuitions of a creature embedded in time, moving through the block from one coordinate to the next, experiencing time sequentially because that is what its nervous system is built to do. But the universe does not share our parochialism. The universe does not distinguish between past, present, and future in the way we do. From the perspective of the block, from the outside, so to speak, every moment is simply a location. And this is where I want to return to light one final time, because light is unique among all the things in the universe in its relationship to time. Everything with mass ages as it moves through time, a rock sitting on the ground, a planet orbiting a star, a human being living their life, all of these things move through time in a way that accumulates age. Clocks tick, atoms oscillate, entropy increases. But for a photon, a massless particle of light, something extraordinary happens. A photon, traveling at the speed of light, does not experience time at all. From the photon's own frame of reference, if we can speak loosely of such a thing, the moment of its emission and the moment of its absorption are the same moment. There is no duration. There is no travel time. The photon that left a star in Andromeda 2.5 million years ago and the photon that enters your eye tonight are, in a very specific technical sense, the same event seen from different angles in space-time. This is deeply strange. It means that light, the very thing that connects all of us across the void of space, is itself a kind of bridge across time, a thread that from its own perspective makes past and present simultaneous. The photon does not experience the journey. The photon does not know that 2.5 million years have passed on Earth between its emission and its absorption. For the photon, there is only a single instant, and that instant contains both the ancient galaxy in which it was born and the eye of the observer on Earth who receives it, connected in one seamless geometric event. This is why I say that light proves the past is still happening, not in a poetic sense, not as a metaphor, but in the literal physical sense that the photons currently reaching your eyes from the night sky are still in motion, still connecting the past to the present, still maintaining a real physical link to events that occurred millions or billions of years ago. Those events are not simply remembered. They are not merely recorded in the fossil record of matter. They are still causally connected to the present moment by unbroken chains of photons crossing the dark. When Hermann Minkowski stood before an audience in 1908 and said that henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality, he was pointing at something that took the scientific community decades to fully absorb. The union of space and time into space-time means that the geometry of the universe is four-dimensional, and in that four-dimensional geometry, every event is a fixed point. Not fixed in the sense of motionless, fixed in the sense of permanent, real, indelible. I spent my career trying to understand the hidden architecture of matter and light, trying to find the deep principles beneath the phenomena. My hypothesis about the wave nature of particles, which earned me the Nobel Prize in 1929, was an attempt to unify what seemed like contradictions, to show that the world is more whole, more coherent, more mathematically beautiful than our surface-level experiences suggest. The block universe is the same kind of unification, applied not to the categories of wave and particle, but to the categories of past and present. We are accustomed to thinking of reality as a moving point, a single moment called now that slides forward through time, leaving the dead past behind and approaching the unknowable future. But what if reality is the entire line? What if every point on that line, every moment, every event is equally real, equally present in the geometry of space-time, and the only reason we experience a sequence is because our bodies, our brains, our consciousness is itself a sequence of events embedded in the block, reading it from the inside. The light that reaches your eyes from the stars is not just beautiful, it is not just ancient, it is a message in the language of physics written in photons saying, I came from somewhere real. The moment of my birth was a real moment. It still exists. It is still part of the structure of this universe, and I have carried the evidence of its reality across the dark, across the millions of light years, and I am delivering it to you now, at this moment that you call the present. The past is not gone, the past is far away. And in a universe where space-time is a single continuous geometry, and where light bridges the distance between all events, far away and gone are not the same thing. They have never been the same thing. We simply had to wait for physics to grow large enough, ambitious enough, strange enough to tell us the difference. So tonight, when you step outside and look up at the sky, I want you to see it differently.